Hi, in this video, we're going to talk about inverse function. Now, imagine I have a graph, and my graph looks something like this. Okay. Now, I want to find what is the inverse of this graph. So let's call this graph y equal f of x, just a general function notation form. So how does the inverse look like on the same axis? So the inverse and the original are reflected on the line. So let's call the line the middle here. This line is y equal x. All right. So the inverse the graph that reflected on the line y equal x. So if you think about, let's say this point right here is 0, comma 4. So when you 0, comma 4, when you reflect it on this line, it will become here. So this will be the new point here. And I'm going to use the red. So this will be 4, comma 0. Okay. So inverse function, if you have x, y, is reflected in line y equal x. It's actually y and x now. So the x and the y swap around. And your shape will look something like this. And this we call an inverse graph. And to inverse, we write that as f negative 1 of x. Okay. Now we're going to have a few main things to remember here. So inverse function is written at f negative 1 of x is a function that is reflected on the line y equal x, as you can see on the graph here. Now, to further rule of the inverse function, by definition, when you have x, y, it's become yx. So for that reason, if they give you the original equation and you want to find the rule of the inverse, what you do is you're going to swap x and y in the equation, and then from here, you're going to solve for y. Then example underneath, and we're going to do some of the examples together. Now, to make the inverse function exist, so the inverse exists, but is this a function or not? So that's the question, right? Now, think about if you have a graph that looks like a parabola, for example. When you reflect it on the line y equal x, how does that actually look like? So think about this part here. When you reflect it, it's become this part. So half of the parabola will become like that. And if you think about this one, the one that if you look at the math right here, when I reflect it on the line y equal x become like that. So you can see the original is a parabola. So the original is a function, right? However, if you look at the inverse is the inverted parabola, which is not a function because it doesn't pass the vertical test. So for that reason, some function will have the inverse, some function will not have the inverse. So what's the condition to make the inverse function exist? So at the moment, you can see the original function here is manage one, and you is a parabola. So this is manage one here, right? However, if I have let's say I have a square root graph that look like this, then this is 1 to 1. So when I do the inverse, it's go like that. So it's actually the inverse is a function because it's past the vertical test. So you can see even manage one relationship, the inverse function will not exist. But if one-to-one function, then inverse function will exist. Okay, so we're going to write here as to make the inverse function exist, the original graph f of x have to be a one-to-one. So one-to-one means it cut the horizontal, it's past the horizontal test, so it cut once, and vertical test is also cut once. Now, the domain of the inverse, because the domain is the x value, and as you know, when the inverse, they swap x and y, so the domain of the inverse is the range of original, and the range is the y value. And oppositely, the range of the inverse is the domain of original. Okay. Now, the inverse function and the original function, and we can see here on the graph, the inverse and the original. If you look at this point here, you can see that they are intersecting on the line y equal x. So whatever the intersection happening between these two curves is always happen on this line. Okay. So the inverse function, original function are the reflected on the line y equal x, and the intersections is also lies on the line y equal x. So for that reason, to find the intersections between the original and inverse, so if you want to find this point here, one way you can do is you just let fx equal to f. It's easier instead of letting fx equal f inverse. So to find the intersection between the original and inverse, we just let f of x equal to x. Okay, and we can solve x from there. All right, now we're going to go over some example. Find the inverse of 2x minus 3. So we have y equal to x minus 3. And to find the inverse, we say we swap x and y. So what we have here, we have x equal to y minus 3. And then we're going to solve for y. So x plus 3 equal to y, then get the 2 divided by 2 on the other side. So there, now you have an inverse equation. What we have is we have therefore f inverse equal x plus 3 over 2. All right, now here's some more example how to find the inverse of each graph here. So here you can see this is the domain and this is the rule of the equation. Okay, so we're going to do by the rule first. So we have y equal to x plus 3. We swap x and y, x equal to y plus 3. We solve for y. So we have x minus 3 over 2 equal y. So therefore, the inverse equation for this 2x plus 3 will be x minus 3 over 2. Okay, so we done that part. Then now they ask you about the domain and range as well. So with the domain and range, we talk about the domain of the origin inverse is the range of original. Oh, sorry. And the range of the inverse is the domain of original. So what we got to do, we just need to find the domain and range of original, and we can swap them around. All right. So you can see this is the domain. This is the domain of the original. So this will become the range of the inverse. So the range of the inverse equal the domain original, which is this, will be equal -2 and 1. Okay. Now what we got to do, we're going to find the domain of the inverse. Now to find the domain of inverse, we're going to find the range of original. And in order to do that, we're going to think about what does this graph look like? The original graph look like. So if I sketch this roughly, you can see the original is a linear line, have to one to separate three, and it's go like that, right? Now, this is the domain of the original, so they want to restrict it from -2 to 1. So -2 is somewhere here to 1. So you can see that I've cut this graph off. So my graph, if I do it again, is only from there to there, okay, including. So to find the range, you're going to find what's the y value here and what's the y value here. And I know that x equals -2 and x equals 1. So all I do is just substitute that in. So with x equals -2, I have y equal 2 times -2 plus 3. -4 plus 3 is -1. So I know that this will be -1 here, the y value. And I do the same thing. When x equals 1, I sub it in. 2 times 1 plus 3, that give me 5. So 5 here. So I can see that the range is 1 to -1 to 5. So this will become the domain of original, and my answer is -1 to 5. All right. Now we're going to move on to sketch the inverse functions. And this is pretty much what we said early on the top. To sketch the inverse function, you first of all you draw the line y for x in the middle, and then you reflect f of x, the original equation, on this line, on the line y for x. Okay, so if you have the point x, y, when you reflect it, it's become y and x, like that. Okay, here we do have an example here. So here they give you the original equation, which is a hyperbola, and they want you to sketch both of them on the same axis. So if I do this, I have the asymptote as y equals 3, right? And x equals 0. So I have here x equals 0. I mean, this is a positive hyperbola, so your shape will look like this. Okay. Now they want to sketch the inverse. So to sketch the inverse, x equals 0 will become y equals 0. So the y equals 0 will be here. Okay, and y equal 3 will become x equal 3. So x equal 3 will be here. So these are the new asymptote of the inverse graph. Now what you do, you draw the line y equal x in the middle. So that's like y equal x here. That is the line in the middle. And then you're going to reflect the original vice the line y equal x. And these are the, you can see these are the asymptote, the blue one is the asymptote. So think about if I reflect the black line on the line y equal x, and these are the asymptote. So I can see my graph will look something like this. This will be the first part, okay? And same thing, this is the black one, the black line on the second one, and I want to reflect on the red line, and these are the asymptote. So I know that my graph will look something like this. All right, and yeah, this example is pretty much the same thing. Okay. Now, just one thing, when you have these type of questions, x plus 4 on x plus 1, this is actually a hyperbola. So how do we convert this to hyperbola format? What we do is the two way think about it. You can use long division or you can do this method. So if you have x plus 1 here on the top, number 4, you're going to break into 1 and 3. So 4 break it up into plus 1 plus 3 over x plus 1. Okay. And then you will have x plus 1 over x plus 1. So you split them up. Plus and then 3 over x plus 1. So you split them up into two fractions. X plus 1 over x plus 1 equal 1 plus 3 on x plus 1. So this is one way you can make a hyperbola. Another way, which is more common and it can apply in harder case, is just use long division. So if I have, so on here I have x plus 4 on x plus 1. So you do like that. So x divided by x, that gives you 1. And then you multiply backward. 1 times x is 1x. 1 times 1 equals 1. And then you subtract the mean between. So x minus x go away. 4 minus 1 is 3. So you will write as x plus 4 over x plus 1. So 1 is the quotient. So you write 1 plus. This is the remainder. So remainder right here. 3 over the denominator x plus 1. So either way. And then you can find the inverse of this graph after that. All right. Now, to restrict the domain of the original, to make the inverse function exist, we talk about that f of x have to be a one-to-one function. Okay. So some graph might not be one-to-one and you need to cut it off. Here I have an example. I have a parabola. This is my restricted domain. So they say if b is the smallest real number, should that g have an inverse by the value of b and by the rule for the inverse. All right. So if we think about the original graph, which is a parabola, this one we can write x plus 4, and it has the asymptote as 0 and -4. So we know that it looks like that, right? So this is managed one because you can see it doesn't pass the horizontal test. So we need to cut it off. So to cut it off, b to infinity, we need to make this one-to-one. So we're going to make g of x one-to-one, okay? And to make it one-to-one, we cut from the turning point. And they want b to infinity, so infinity on this side. That's infinity. So we only want this first half of the parabola. So we don't want this. So this will be the middle between 0 and -4, so -2. So we know that b is -2. And then find the rule of the inverse, which is swap x and y. So to find G inverse, we're going to swap x and y. So swap x and y. So here I have the rule is y equal x squared plus 4x. So now I swap x equal y squared plus 4y. And I'm going to solve for y. Now, because here you have 2y, you have an option. You can complete the square to make it into 1y. So to complete the square, you will have x equal y squared plus 4y plus. So you have a 4 is 2 and 2 squared equal 4. So you would do plus 4 minus 4. So this one will end up equal y plus 2 squared minus 4. Then you bring the 4 over. So x plus 4 equal y plus 2 squared. To carry up the square, you have to square root the other side. Now, usually when you square root, you're going to end up having 2 answers in the front, right? And because for the inverse, you only have 1 answer. So if you look at this, they tell you that the domain is b to infinity. So you can see they go to infinity for the domain of the original. So if they go to infinity of the original, then the inverse, the range of the inverse need to go to infinity. So you need to pick the positive square root to make it go to infinity. Okay, so in here we just do square root. And then move the 2 over, so you will have x plus 4 minus 2. And that will be your inverse equation. Okay, here's another example. Pretty much the same thing, but in this case, you can see that they go to negative infinity instead. Here, we do the same thing. To find the inverse, to find a, we need to restrict it. So we factorize that at x minus 6. We have a parabola that looks like this, passing 0 and 6. Now, because we want to restrict the domain negative infinity to A, so we know that to make it 1 to 1, it have to be here. Okay, so we cut these off. So we do the same thing to make it fxc 1 to 1. I have to be equal up to the turning point, which is half of 6 in 3. So we have 3 here. And then to find the inverse, we do the same thing. We swap x and y. So to find f of -1, we're going to swap x and y in here. So we have y equal x squared minus 6x. Now we swap x equal y squared minus 6y. We're going to complete the square. So half of 6 is 3. 3 squared is 9. So we plus 9 minus 9. Then this one is y minus 3 squared minus 9. And then here we will have x plus 9. And then can you see that when you need to carry up square, so you have, okay, let's take it slowly here. I have x plus 9 equal y minus 3 squared. Okay, now to carry up square, you square root the other side, but you could have plus or minus in the front, right? Now, because the domains go to negative infinity, this means the range here will go to negative infinity. So you're going to pick the negative instead. So this will be negative, okay? And then put the 3 over, so negative x plus 9 plus 3 equal y.